Okay, so today we're going to be looking at some new identities. We're going to be doing section 5.4 out of your books, which is on the sum and difference. My pen's not working here, bear with me. The sum and difference identities. Now, I need you guys to get your identity sheets in front of you, and you're also going to need your trig table or your unit circle. Okay, so what we're going to do to start today's notes is if I ask you guys to find for me the sine of 75 degrees, if you look at your trig table, you can see that 75 degrees is not on there. However, I can make 75 degrees by using two angles that are on my trig table. So I can say that the sine of 75 is the same as the sine of 30 plus 45 degrees. The sine of 75 and the sine of 30 plus 45 are in fact the same angle. So now what I can do though is, since I've turned this into the sine of something plus something else, if you look on your identity sheet, towards the middle there should be a box that says sum and difference identities. I can see that the sine of x plus y is equal to the sine of x times the cosine of y plus the cosine of x times the sine of y. That's the identity I want you guys to be looking at, because that's what I have now with the sine of 30 plus 45. So I can say that the sine of 30 plus 45 is going to be the sine of 30 plus, sorry, let me erase that and get my handy dandy little eraser here. The sine of 30 times the cosine of 45. That's my sine x cosine y, because this is basically my x and this is my y, plus the cosine of 30 times the sine of 45. Sorry, my handwriting is really bad here with this pen. Okay, so now you're going to go to your trig table. The sine of 30 is a number. I can pull that off of there. The sine of 30 is 1/2. The cosine of 45 is a number. That is radical 2 over 2. The cosine of 30 is a number. That is radical 3 over 2. And the sine of 45 is a number. That is radical 2 over 2. So I'm pulling all those straight from the trig table. Now, these are two fractions that you can multiply straight across together. That gives me radical 2 over 4 plus, these are two fractions you can multiply together. That gives me radical 6 over 4. And if I add those together, that gives me radical 2, thanks, plus radical 6 over 4. So that is my answer for this question. Okay, so we just found an exact answer for the sine of 45, or sorry, the sine of 75 degrees. Let's try another one. Now this one, I'm going to make it harder because I'm going to give it to you in radians. If I ask you for the cosine of pi over 12, you've got to find two angles that add or subtract to pi over 12 on your trig table. Now, you probably don't know that off the top of your head like we did with 75 degrees. So why don't we take pi over 12 and convert it into degrees? And I can convert radians into degrees by multiplying by 180 over pi. Pi's cancel. You can do 180 divided by 12 on your calculator. That's going to give you 15 degrees. So the cosine of pi over 12 is the same thing as the cosine of 15 degrees. So then I can say 15 degrees is really 45 minus 30. That is a separate trig identity. If you look on your sheet, the cosine of x minus y is the cosine of x times the cosine of y plus the sine of x times the sine of y. So if I have the cosine of 45 minus 30, then this is my x and this is my y. I can write that as the cosine of 45 times the cosine of 30 minus the sine, plus the sine of 45 times the sine of 30. And the cosine of 45 is radical 2 over 2. I'm getting that off of your trig table. The cosine of 30 is radical 3 over 2 plus the sine of 45 is radical 2 over 2. The sine of 30 is 1/2. And that's going to give me radical 6 over 4 plus radical 2 over 4, which is radical 6 plus radical 2 over 4. So that is an exact answer for the cosine of pi over 12, or the cosine of 15 degrees. Now what we can do is we can say, well, what if, let's just do another one here. I want to know what the sine of 165 degrees is. Okay, so again, that's not on my trig table, so let's find two numbers that are. So I'm going to do the sine of, there's a few things that work, but let's try 120 plus 45. Pretty sure if I add those together, 120 plus 45, that gives me 165. So looking at your identity sheet, that's going to be the sine of 120 times the cosine of 45 plus the cosine of 120 times the sine of 45. So now we go to our trig table. The sine of 120 is radical 3 over 2. The cosine of 45 is radical 2 over 2. Plus the cosine of 120 is negative 1/2. Sine 45 is radical 2 over 2. So that gives me radical 6 over 4 minus radical 2 over 4, which gives me a final answer of radical 6 minus radical 2 all over 4. That's an exact answer for the sine of 165. Now, if I say go ahead and do another one here, let's do the cosine also of 165. I already have my two angles. I'm going to keep that 120 plus 45. So again, just drop it into your identity, but we're using a different identity. This is cosine of a sum. So cosine 120, cosine 45 minus sine 120 sine 45. So now that's going to be the cosine of 120. Go to your table. That is negative 1/2 times radical 2 over 2 minus the sine of 120 is radical 3 over 2, radical 2 over 2. That gives me negative radical 2 over 4 minus radical 6 over 4. And if I combine that, that gives me negative radical 2 minus radical 6 all over 4. So that's my exact answer for the cosine of 165. Now, if the sine was radical 6 minus say then what's the tangent of 165, you could use the identity that you see on your sheet. But since I already found sine and cosine, why don't I just do the sine of 165 divided by the cosine of 165? Since I already know those, let's use the quotient identity. So going back, Sine was radical 6 minus radical 2 over 4 over, and the cosine, I believe, was negative radical 2 minus radical 6 over 4. I think that's right. Hopefully that's right. I'm trying to do that off of memory there. Well, then that's going to be radical 6 minus radical 2 over 4 times 4 over negative radical 2 minus radical 6. And the 4's cancel, and that's going to give me radical 6 minus radical 2 over, that's a radical, negative radical 2 minus radical 6. And then from there I can multiply by the conjugate and blah, 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 blah. So you can look at that one example in my homework and figure that one out. And I got one more example to show you. Okay, so for the last thing we're going to do here, it's going to look like this. We can also do a verify question. So here's a verify. The cosine of pi over 2 minus x equals the sine of x. So this is a trig verification question. So we know that when we do a trig verification, I'm going to pick a side and recopy it. That side looks harder. That's the cosine of pi over 2 minus x. I somehow need to prove that that becomes the sine of x. Well, I can see here that that's nothing more than the cosine of a difference. So cosine of a difference, look on your identity sheet. That's going to be the cosine of the first times the cosine of the second plus sine of the first, sine of the second. And now I can go to my trig table. The cosine of pi over 2 is 0 times the cosine of x plus the sine of pi over 2 is 1 times the sine of x. And 0 times cosine x is gone. 1 times sine of x is sine of x. And I matched that to this, so I am done. And there you have it. That's what we're doing with sum and difference identities.